Hi, welcome to video 9.4b, the limit comparison test. Just a quick review from this point forward. Obviously on every test, I cannot separate this out. You're going to have to be used to picking out which test to use. So these are the ones we've learned. The one I will not put on anymore is sequence of partial sums. That's because that's so rare. But you should check first for nth term test, geometric series, integral test, p-series, harmonic series, direct comparison, limit comparison, and unfortunately we will keep adding to that list. So the limit comparison, forget what the book says. This is what I prefer you to know. So if you have UN and VN, again, you're going to have to come up with the VN. They both have to be series of positive terms. And basically what happens is you're going to decide whether your series VN is convergent or divergent. But then the beauty of this one is you're looking for the same limit in each case. The limit is n goes to infinity of UN over VN. If that limit is a positive constant, then both series converge or both diverge. So if you found out series Vn was convergent and the limit is n goes to infinity of UN over Vn is equal to 5, let's say, then your series UN is convergent. If this one was divergent, then this one will be divergent. If the limit is n goes to infinity of UN over Vn equals 0, and if the summation Vn was convergent, then your original series UN is convergent as well. However, please note, if this limit is 0 and your VN was divergent, there's no conclusion and you'd have to try another test. Final situation is if that limit is infinity and if you're comparing it to a divergent series, then your original series would be divergent. If that series you were comparing it to was convergent and this limit was infinity, there would be no conclusion. You'd have to try another test. Okay, so here's numbers 15 through 28. It actually says use the limit comparison test. Notice this starts at 3, very good reason. If it started at 0, you'd have the square root of a negative, which is imaginary. If it started at 1, you'd have the square root of a negative, which is imaginary. And if it started at 2, you'd have a denominator of 0, which is impossible. So first thing we're going to do is come up with what is Vn. And the 3 is insignificant, but what I have on the bottom is the square root of n squared, so 1 over n is what I'll have. Make sure you start at 3. This is the harmonic series. It's only missing the first two terms, therefore it's divergent. Now we're using the limit comparison test, so we're going to find the limit of un, which is this, over vn, which is that. And first I'll simplify. And at this point, I have the degree of the top is 1. In effect, the degree of the bottom is 1. It's going to be leading coefficient over leading coefficient, which is 3. So since that limit is a positive constant and we were comparing it to a divergent series, then our series is also divergent. This one, they're asking you to use each test once. There is something called the telescoping series test. You're not responsible for that. So this is like number 30. If you write out the first 3 terms, you'll realize it is a geometric series. So really, it's not that it's called the geometric series test. I don't know where they're getting that from, but it is a geometric series. Common ratio is -1/5. Since the absolute value of the common ratio is less than 1, it converges. Okay, so here's another one like number 32. It's telling you to use the limit comparison test. So again, notice this starts at 4. Main reason being if it started at anything smaller than that, it would be a negative. And we can only use limit comparison test on series of positive terms. So they are all positive. We're going to compare it to 1 over n squared, get rid of the non-leading terms, and get rid of the coefficient of the leading term. So it's just 1 over x squared. That's a p series. It happens to be missing the first 3 terms. Who cares? At p is equal to 2. Since p is bigger than 1, the series converges. So now we're going to find the limit is n goes to infinity of un over vn. So here's my un right here. My vn is 1 over n squared. If I multiply by the reciprocal, I get the following. Degree of the top equals degree of the bottom, so it's leading coefficient over leading coefficient, so that's equal to 1/3. Since that is a positive constant and we were comparing it to a convergent series, then our series un is also convergent. So again, just a quick review, given a sequence of partial sums, geometric series, nth term, integral test, p-series, including harmonic, direct, and direct.